How's it going, Algebra 1? It's Mr. Knight, and yesterday we looked at adding and subtracting polynomials. Today we're not going to multiply polynomials yet, but we are going to do something that builds up to that. So we're going to start off with a monomial, a single term, and we're going to multiply that to a polynomial, a chain of terms, okay? So there's two things we're going to need. First thing, we're going to need our distributive property. So recall, if you have a number on the outside of something in parentheses, you can multiply that outside number to these inside numbers, and you'll end up getting a times b plus a times c. Okay? Also recall our product rule from the last unit. If I have x to the a power times x to the b power, well, to combine that base, I get x to the a plus b power. I just add those exponents for the like bases, okay? So combine it with the c's if you see multiple c's, combine it with the d's, combine it with the x's, whatever your base ends up being. So let's put both of these rules to the test in monomial times a polynomial. And looking at this, we have a monomial times this polynomial right here for number 2, just as an example. Okay? So again, we're going to take this outside monomial and I'm going to distribute it. I'm going to multiply it to each thing in here. Okay? K to the first times k to the k to the first times k to the first, that's k to the second power using my product rule. And then k times negative 9 is negative 9k. And that, guys, is as simplified as possible. And there we go. That is just all we're doing. Okay, it get a little bit more complicated, especially when we start throwing in some coefficients and whatnot. So let's see what that'll look like for number 8. Okay, again, number 8, I have this outside monomial. I'm going to distribute it to each part of this polynomial. So 5m squared times 3m squared. Well, we do 5 times 3 and get 15. And then I use my product rule for the m's. M to the second times m to the third is m to the 5th power. And now we're on to this one. Again, 5 times, well, there's no number out in front, so it's just a 5. But it's a negative times a positive 5, so it's a negative 5. And it will be m to the second times m to the first, so that is m to the 2 plus 1, so the 3rd power. And then this one's going to be 5m squared times negative 7. That is going to give me negative 35. And then it's going to be m to the 2nd power. And that guy is done. That's as good as we can get. I can't actually add or subtract those. They are not like terms. Okay? Let's try something a little bit more complicated. Let's try 14 now. Okay? Again, taking this outside monomial, I'm going to distribute it to each part of this polynomial. Watch your signs especially. So negative 4 times 9 is negative 36. And now let's use our product rule with the c's and the d's. C to the third times c to the second is c to the 5th. D to the second times d to the second is d to the 4th. Just adding those exponents. And now we're to the next one. So negative 4 times negative 4 is a positive 16. C to the third times c to the first is c to the 4th. And then we're going to get d to the 7th power, and that is multiplied. There we go. Okay. So that's all we're doing with monomials times polynomials. We're not doing anything other than that. I mean, as long as you remember these two rules, distributive and the product rule, you should be good to go. What might trip you up a little bit more is when we start incorporating what we did yesterday. The addition to subtraction, okay? Now, because of PEMDAS, we're always going to multiply first. We're always going to look to distribute first, okay? So let's try it with like number 17. So I notice I can distribute twice. I can distribute this guy, and I can also distribute this guy, okay? Notice I'm distributing as many times as I need to, depending on how big my polynomial is, okay? So now I'm just going to do my product rule like I did last time. Okay, 5w times negative 7w. I'm going to go a little bit faster. 5 times negative 7 is negative 35. W times w is w squared. 5w times 3 is a 15, positive 15w. All right, we move on to like now this guy right here. Okay, 2w times negative 2w squared is going to give me, well, it's a 2 times negative 2 is negative 4. And then w times w squared is w to the third. I got 2w times 19w. 2 times 19 is 38. W times w is w squared. And 2w times 2 is just a 4w. All right. Now, normally, I would be done if it was, just something like up here. But we can simplify this. We can actually add and subtract, okay? Is there a like term of negative 35w squared? There is. This 38w squared. So negative 35 plus 38, that gives me a positive 3w squared. I don't change my exponents or variables. Right? I'm just combining like terms. 15w plus 4w, that is 19w. And then it's going to be finally a minus 4w to the third. I can't forget about that guy. Oops. I can't forget about that exponent either. Sorry about that, buddy. Okay, so multiply, look to distribute, and then add and subtract accordingly. Okay, let's try it one more time. Let's do it with number 21 right here. So we have 3 things we can distribute, and we're going to go ahead and do that. Whoa, a lot to distribute. Now, I'm not distributing just a 3y. I'm doing negative 3y. Okay, I'm just taking the whole sign with me, just like I'm taking this negative 3y with me. So multiplying these, I get negative 21. This will be y to the second. And this will be a positive 6y. This one, I'm going to get a positive 3y squared. 3 times 2y is 6y. 3 times 1 is 3. Now we're here. Negative 3 times negative 5 is a positive 15. Y times y is y to the second. And then negative 3y times 3 is minus 9y. And let's look to combine like terms as much as we can. Negative 21y squared and 15y squared and 3y squared, those guys are all like terms. So negative 21 plus 3 plus 15, if you put it on your calculator or you just know, it'll be negative 3y squared. Then I have a 6y plus 6y minus 9y, so I get a positive 3y. And then finally I just have this plus 3 that's chilling. Oh my god, they're all 3s. 3, 3, 3. Hello. And that guy is done. And there's one more type of problem that I want to go over with you guys, and that'll be on the back side. Another geometric application. I want us to find the area of this shaded region. Now, if you're looking at just the shaded region, that is not a known shape. It's kind of not really a shape that we work with at all. But let's look at the shapes we do know. We do know we have this inside shape, a rectangle. We have an outer rectangle. So if I want the area of these, that would be the same thing as getting the area of the big guy and then taking away the area of this little guy, and I will be left with the area of the shaded region, right? I just kind of flip-flopped them for this case, right? So that would be finding the area of big rectangle. And then if I take away the area of this guy, that'll give me just the area of the shaded region. So that's the area of the big rectangle minus the area of the small rectangle. So let's find those areas. We know the area of a rectangle. It's length times width. And we have a length times width for both these problems. Let's start with the bigger rectangle. For the big rectangle, I got, for my length is 8x minus 1. My width is 6x, so I got to multiply those. Minus area of my small rectangle, my length for that one is 5x plus 3 times 2x. So I got to multiply those first. Let's go ahead and do that. Again, let's treat it like distribution. I know that my monomial is in a parentheses, but that's okay. I can still do it like this if I'm multiplying. I have to distribute it to both these, okay? Now, when we do this, we end up getting 48x squared minus 6x. Okay? For this one, what I'm going to do, because this might actually trip us up, I should have wrote the 2x out in front so we knew this was a negative 2x. What I'm going to do, I'm going to make that positive and change that 2 to a negative. Okay? It'd be doing the same thing if this was a negative 2. It should be. I just didn't write it like that. Okay? But if I now look at it like this, now I can do negative 2 times 5x. I get negative 10x squared. And then 3 times negative 2x is negative 6x. Combine like terms. 48 minus 10 is 38x squared. And negative 6x minus 6x is minus 12x. And that would be the area of the shaded region around this place. Hope you have a good one. This is Mr. Knight signing off.